Very good morning. Welcome to this session. In this session, we are going to discuss a topic called multi-stage rocket systems in the subject rockets and missiles. In the previous class, I discussed the single-stage rocket system. Here, we are moving on to the multi-stage rocket systems. So let's see one by one. First of all, we should know what is a multi-stage rocket system. A multi-stage rocket system is a launch vehicle configuration in which two or more rocket stages are arranged one above another and operate sequentially during flight. Each stage contains its own propulsion system, fuel tanks, accelerator, then accelerator tanks, structural frame, and control components. The basic principle of a multi-stage rocket is to discard the empty or exhausted stages during the ascent so that the remaining vehicle becomes lighter and more efficient. This concept greatly improves the rocket's ability to achieve the extremely high velocities required for satellite launching as well as space exploration and interplanetary missions. Multi-stage rockets are widely used in modern aerospace engineering because a single-stage rocket is generally unable to carry sufficient fuel and payload simultaneously while reaching the orbital and or escape velocities using conventional chemical propulsion systems. The operation of multi-stage rocket begins with the ignition of the first stage at a launch. The first stage generates very high thrust to lift the rocket from the launch pad and overcome its gravitational force and atmospheric drag. Once the fuel in the first stage is exhausted, the stage is separated from the vehicle. The next stage is then ignited to continue the accelerating the rocket. This process continues until the final stage delivers the payload into the desired orbit or trajectory. By removing dead weight after each stage burns out, the rocket experiences continuous reduction in mass, resulting in improved acceleration and propulsion efficiency. This staged operation allows rockets to achieve higher velocities than would be possible with a single large stage carrying all empty tanks and engines throughout the mission. Multi-stage rocket systems can be classified into different types based on stage arrangement and operation. The most common type is the serial staging system, where stages are stacked vertically and operate one after another. Another type is parallel staging, in which booster rockets attached to the sides of the main vehicle operate simultaneously during the liftoff and are separated after fuel depletion. Some advanced launch vehicles combine both the serial and parallel staging to achieve greater thrust and payload capability. Depending on mission depending on mission requirements, rockets may use two-stage, three-stage, or even more complex staging arrangements. The choice of staging depends on payload mass, mission altitude, orbit type, and propulsion technology. Here the figure has been illustrated. This illustrates the concept of rocket staging and it explains how the number of stages in a rocket system influences the overall launch configuration and payload delivery capability. In the first configuration shown at the top, a single stage rocket system is represented here. This arrangement consists of only one propulsion stage attached directly to the payload. The entire launch stack includes the first stage and the payload section. In this system, the same stage must perform all operations such as lift-off, atmospheric ascent, acceleration, and payload delivery. Since the stage remains attached throughout the mission, the rocket must continue carrying the empty fuel tanks and structural mass even after fuel exhaustion. This reduces propulsion efficiency and limits the achievable velocity and payload capacity. Since single stage systems are simple in construction and operation, but they are generally unsuitable for high altitude orbital missions due to their poor mass efficiency. The second configuration in the middle section, it represents a two-stage. It represents a two-stage rocket system. Next, we will see on the stage separation and ignition sequence. The stage separation is one of the most important. It is a important process in a multi-stage rocket system where an exhausted rocket stage is detached from the remaining vehicle during flight. The primary purpose of stage separation is to remove the empty fuel tanks, engines, and structural components that are no longer useful after propellant consumption. By discarding this dead weight, the rocket becomes lighter and more efficient, allowing the next stage to accelerate the payload more effectively. Stage separation usually occurs at a high altitude after the completion of stage burn. The process involves carefully designed mechanisms such as pyrotechnic devices, explosive bolts, pneumatic pushers, or spring-based separation systems to ensure smooth detachment. After separation, the next stage engine ignites automatically and continues the mission. Proper timing and synchronization are essential because any failure during the separation can result in mission loss. Engineers must also consider aerodynamic suitability or aerodynamic stability, structural loads, and guidance control during the separation event. Modern rockets use highly reliable stage separation systems to improve safety, payload delivery capability, and overall mission success. So that's all for today's class. We will see in the next class with a different topic. Thank you all.